Jane Gilbert published this article, Science 2.0 in School Science, in New Zealand Science Teacher, issue 131, pages 5 through 9. The article refers to prior work, done in 2011, which found pressure for change in science education, driven by changes in society, attitudes towards schools, and new theories of learning. Leaving those aside, the current article discusses changes in science itself. The Prime Minister's Chief Science Advisor, Sir Peter Gluckman, also noted the nature of science has changed in his report on science education, highlighting in particular the shift to knowledge expressed as a probability, never an absolute. In addition, the way scientists work together has changed, as John Ziman explains in his book, Real Science. Because scientific study often requires use of expensive equipment, scientists work collectively. And because exploring scientific questions often requires multiple perspectives and skills, the work is transdisciplinary. The mismatch with teaching individual students to pass a chemistry test should be obvious. That old approach to science education is outdated, narrow and discipline-bound. David Weinberger's book, Too Big to Know, explains how the nature of knowledge itself has also changed. Rather than being something we have, knowledge is now something we do. It is conditional, not absolute, and much, much bigger than we can grasp as individuals. Knowledge is collective and networked. As this graphic shows, even a graduate student in engineering will learn only a sliver of the expanding circle of human knowledge, but the knowledge enables collaborative engineering work. Again, the drawbacks of requiring science students to master a large set of facts, such as the periodic table, should be obvious. Learning to design experiments and communicate findings would be far more useful. Science needs people able to connect with the knowledge of others. Scientists need to articulate their contribution, and listen, interrogate and negotiate with other scientists. Doing these things requires well-developed thinking and interpersonal skills, and then it involves making discoveries in the spaces between the experts. Tony Wagner's book, Creating Innovators, points to conditions needed for innovation, including opportunities to work with others with different skills, to solve real problems that all participants care about. Again, an academic emphasis on learning existing knowledge as a measure of individual achievement does not help develop the necessary skills. Sharing emerges as a core competency for science. So science educators should begin actively working with sharing tools, particularly public, collaborative resources such as Wikipedia and Slide Speech. Moreover, when teachers share their own professional development, it models the learning skill for students. Jane Gilbert's article raises important questions for further discussion.